Hello and welcome students. In last video we learned about 1 onto function. In this video we are going to see what are 1 into functions. So for that I have drawn here arrow diagram wherein you have two sets. One is here domain set. This is domain set, and this side on the right you have the codomain set. I want you all to see this arrow diagram very attentively, have high degree of concentration, and you need to find out what function is this. So definitely you understand if the arrows are originating from domain set elements and they are ending on uh, the elements of the codomain set, which will form later on the range set. There has to be some function in between this, and that underlying rule is, say, f. So you have to look at the arrow diagram, you have to find out what relation is there between these elements of the domain set and the codomain set, and then you have to write it. What function is this? You can pause the video and check what function is this. Okay. Yes, very good. You guessed it correctly. The function here is, if you call this as, if you call all these elements as x, these elements of the domain set, if you are representing by the variable x, and the elements of the codomain set, range set, you you represent it by y, then you understand that here the elements of element y is every time double of the element x. So you guessed it correctly, it is y equals to 2x. But if you have noticed, there is one major change here, and the change is, this time I am not taking the domain as set of real numbers. You will not find here the numbers like decimal numbers 2.716 or square root of 2. We are having here only integers. You can check all the numbers which I have taken in the domain set are integer numbers. Okay. But so far as the codomain set are concerned, I am taking it as a real set once again. So this function where I have defined, if the function is f, then I would say it is f from z to R. I'm saying Z to R. Why Z to R? Because the domain elements are coming from the set integer. They are coming from integer set, whereas the range elements are coming from codomain set. They are coming from the pool of numbers, the bigger set of numbers from where the range set elements are coming are real numbers. So this codomain set is a real number set. What I want to tell you is, in this domain set you will not find decimal numbers, irrational numbers, fractions. You will not find those numbers here. See, nowhere you see 11 upon 6 or 13 upon 7 or square root of 2. All these numbers you don't see here. You see only integers. But in this you do see numbers like square root of 2, square root of 3. There are infinite number, students. I have not written because practically it is not possible to write. So here, you have square root of 3, square root of 7, all those numbers you have here. Now what happens is, because of this function which is doubling, it doubles the numbers from the domain set. You notice that every integer is doubled, and you see the image in the codomain set. So -3, its image under f is -6, -2 has image as -4, and so on. But at the same time, you notice that there are certain numbers in the codomain set which have Absolutely, they are not image of any number. These numbers are not image of any numbers from the domain set. In the other words, you can say that there is no pre-image for 7 in the domain set. You can check this. There is no pre-image for the for number 7, number 5, negative of 1 by 2. For all such numbers, there are no image in the domain set. Why there are no image? Because the rule is such. What is the rule? The rule is every number in the domain is doubled and then it comes in the range set. So here you understand, if 7 is the element in the codomain set, 7 is the element in the codomain set, then it will be the image of a number which has to be 7 upon 2. But the thing is, 7 upon 2 cannot be included in the integer numbers. If you have here 7 upon 2, if you have here 7 upon 2, I'm writing it, but remember, it should not have been written. Okay, so what I'm doing is actually wrong. See, if you have 7 upon 2, then you can say that this will have image as 7. Okay, but students, you should understand that what I have done is not correct. Why? Look at this, it is an integer set, it is a set of integer numbers, so this 7 upon 2 cannot be here. So I rectify my mistake and I take this back. I rectify my mistake and I take this back. Okay. So now see, 7 has no pre-image here. 7 has no pre-image. So 5 has no pre-image. Negative 1 by 2. Like this, there are infinite numbers in this codomain set which will have no pre-image. There are infinite numbers in the codomain set which will have no pre-image in the domain set. So what I can say is this codomain set of real numbers is not completely used up. It is not completely used up. There are so many numbers lying without pre-image here. And when such is the case, you call such function as into function. It is into function. It is into function. If you remember in the last video, what we had seen was onto function. And in onto function, what you saw that every element was used up. Every element from the codomain set was used up. That is, every element had a pre-image in the domain set. And the reason for that was, even the domain set was a set of real numbers. So students, it all depends on how you define the function. How you define the function, that will decide whether the function is an into function or onto function. So this function is an into function. Okay, so now what I do is I read few statements here which I have already written, and then we will go ahead. So give me a few seconds, I will just clear this off. Okay, here we notice that there will be many numbers in the codomain set of real numbers R which will have no pre-image in the domain set Z. Hence, the range set will be a subset of codomain set. So students, if I start writing the range set, I will have to include these numbers: negative 6, negative 4, negative 2, 0, 2, 4, 6, 8, and definitely many more. Even these will be infinite numbers, but then that range set will always be a smaller set than the real set numbers. It will be a smaller set than the real set numbers. The range set will always be the subset of codomain set, and hence you will say that function is an into function. You will say that the function is an into function. What is the reason for that? The reason is that range set is the range set is subset of the codomain set. Okay, a function here, I read this now, check this out. A function f is said to be an into function if range of the function is a subset of the codomain of function. It is subset of the codomain of function. Further, as you know, y equals to 2x is an 1 1 function. Y equals to 2x is an 1 1 function. Why? Because every element in the range set has one and only one pre-image in the domain set. This completes 1 1 onto function, 1 1 into function. Okay, students, now we have completed this part. We are in a position to define inverse functions. Okay, that I'll be doing in the next video. Thank you.